Hello and welcome. Today we're looking at the topic of alkanes and cycloalkanes, and this is part of Organic Chemistry 1, and today's lesson is presented to you by Science Visualized. Now, before we continue with alkanes and cycloalkanes, we're going to start by looking at functional groups in organic chemistry, and these are basically families of organic compounds that have common structural features. So they have common functional groups are a collection of atoms within a molecule that have a common bonding pattern and react in a typical way that's independent of the overall structure. So for example, if a molecule contains an OH group, so an alcohol for example, has an OH group, that OH part is a functional group, and we expect that alcohol to behave the same way, to participate in similar reactions, irrespective of what the overall structure is. So you could have different types of alcohols, but all of them contain the OH functional group. Functional groups are very important in organic chemistry because they affect the type of reactions that these molecules will participate in. They affect the overall structure. Sometimes, like for example, with alcohols, you have hydrogen bonding, which affects structure and also affects physical properties. And physical properties are things like melting point and boiling point. So for example, if you have hydrogen bond, you end up with a higher melting point and boiling point. Now, common functional groups, examples. Number 1, alkanes. These only contain carbon and hydrogen, and they don't have any double or triple bonds. So for example, you could have a straight chain alkane that has only carbon and hydrogen, or you could have cyclic alkane. Number 2, alkenes. Alkenes contain at least one double bond, and they only have carbon and hydrogen. So for example, this structure here will be an alkene. That will be another type of alkene. You could also have a cyclic alkene. Number 3, alkynes. These ones contain triple bond. So for example, you could have something like this with a triple bond. Again, triple bond. Next, number 4, alkyl halides. These ones contain an alkyl group with a halogen, so Rx, where X can be chlorine, bromine, iodine, or fluorine. So for example, you could have that, alkyl fluoride. You could have a secondary alkyl chloride, and so on. Number 5, we continue with functional group examples, are alcohols. And alcohols contain OH group. So ROH, alkyl group with an OH, and that will be an example of an alcohol. You could also have a cyclic alcohol. You could have methanol, CH3OH. Number 6, amines. Amines contain nitrogen. So for example, alkyl group nitrogen H2, remember nitrogen forms 3 bonds, and that would be a primary amine because it only has one alkyl group. But you could also have secondary amine, so you have 2 alkyl groups, NH, or tertiary amine, where now all the hydrogens have been replaced. So examples would be that for primary amine. That would be a secondary amine. That would be a cyclic amine, and so on. Number 7, ether. They contain carbon-oxygen-carbon bond. So for example, you could have an alkyl group, oxygen, and then another alkyl group. In this case, you have two alkyl groups that are the same. They have 1 and 2 carbons, 1 and 2 carbons. So that's an ethyl group, and therefore the name for this will be diethyl ether. Do not confuse this with number 8, ester. Ester contain carbonyl group and an alkoxy group. So an example of that will be with a carbonyl and then OCH3. That would be an example of ester. You could also have a cyclic ester. And you see you have a carbonyl at this position and you have the alkoxy group. Number 9, thiols. These ones contains SH group. So you have alkyl group SH. An example of that will be RSH. As a rule of thumb, compounds containing sulfur tend to smell really bad. So for example, skunk. Cooking gas, butane, doesn't have any smell, but they usually add hydrogen sulfide, which has like a rotten egg smell, and that makes us know if the gas is leaking. So when we smell that, because our noses are very sensitive to that smell, and even with very low concentration, we are able to detect and know that the gas is leaking. Number 10, sulfides. These ones contain carbon, sulfur, carbon. So an example of that will be alkyl group, sulfur, and then another alkyl group. Number 11, peroxides. These ones contain oxygen, oxygen group. So for example, hydrogen peroxide, HOOH, which is also written as H2O2, that's the simplest example, but an alkyl peroxide, for example, will be something like, say, that, OOH. So these ones are called hydroperoxide. Number 12, related to peroxides, you have what's called disulfides, and these ones contain sulfur-sulfur bond. So an example of that will be this. Number 13, aldehydes. Aldehydes contain an alkyl group, carbonyl, and then hydrogen. So you have a hydrogen on one side of the carbonyl and an alkyl group on the other side. So for example, that will be an aldehyde. It can also be written as CHO. Number 14, ketones. Ketones are related to aldehydes, but now you have an alkyl group on one side of the carbonyl and another alkyl group. It could be the same or different. I'll use R prime to show that it could be different alkyl group. So an example of that will be that ketone, where you have two methyl groups on either side. You could also have other types of ketones. You could also have cyclic ketones. And the way you name ketones is at the end of the parent name, you add O-N-E, and before that you put a position of the carbonyl group. So for example, this is 1, 2, 3, 4, 5. It has 5 carbons. So 5 carbons supposed to be pentane, but now the A-N-E, you replace that with O-N-E, and now that becomes 2-pentanone, where that 2 shows the position of the carbonyl, or you could just say pentane 2-on. Number 15, carboxylic acids. And these ones contain alkyl group, carbonyl, and then an OH. That's different from an alcohol. Remember, alcohol, you had ROH, no carbonyl. So that's an alcohol, but this is a carboxylic acid. So an example of that will be this group here, this compound, And the way you name it is 1, 2, 3, and 4. It has 4 carbons, so that's a butane. So you say butane, and then instead of that E, you replace that with oic acid, butanoic acid, because it has 4 carbons. Number 16, amides. This is different from amines. Remember, amines was RNH2. Amide now, you have R-carbonyl NH2. So an example of that will be this compound here, and that will be an amide. Number 17, acid halides. They contain alkyl group, carbonyl, and then halogen. Remember, this halogen X can be fluorine, bromine, iodine, or chlorine. So an example of that, of an acid halide, will be this. That's acid fluoride. Number 18, acid anhydride. This one contains alkyl group, carbonyl, oxygen, and then another carbonyl, then alkyl group. And these two alkyl groups do not have to be the same. So an example of that will be this compound here. And now you can see that you have the first alkyl group here and the second alkyl group there. Thank you. Now we're done with functional groups, and we're going to continue with alkanes.